Hey guys, welcome to Arweave Frontier, build on the edge of the blockchain. I'm Rohit, your host for this workshop that is powered by Community Labs, a software company and venture studio building the foundational tools and infrastructure in the Arweave ecosystem. This workshop was originally demonstrated to the Virginia Tech blockchain community, but today we bring this to you. This workshop also has a written version linked in the description below. So without further ado, let's get started. So here's an overview of what we're going to learn in the workshop. We start off with a bit of information about data storage on blockchains. We shall see some problems that arise with the existing setups. Then we dive into Arweave, understand how it works, and see how it has the potential to solve some of these problems. Using Arweave, we will build a decentralized image sharing application and in the process learn about the various concepts and components that go into building on Arweave. So let's start with a bit of history about data storage on blockchains. Did you know, despite being a transactional ledger, the first bit of data stored on blockchains was on the Genesis block of Bitcoin? It was a headline from the British newspaper The Times from 3rd Jan 2009. Despite this potential for information storage, Bitcoin consciously continued to exist just as a digital currency payment network. Then comes along Ethereum and other similar networks with the ability to not just process payment transactions but the ability to process computations of arbitrary complexity, opening up the possibility to new technologies like smart contracts, token standards, and along with it, the ability to store information. This was a giant leap for blockchains. However, decentralized data storage was still not the primary focus for these networks, and their unique mining mechanisms meant data storage would be very expensive. The cost of storing data on a blockchain like Ethereum can go up to tens of thousands of dollars depending on market conditions. And due to these expenses, users prefer to store their data on centralized systems despite the benefits that decentralization offers, like immutability, data permanence, and security. Enter Arweave, a protocol that allows you to store data permanently, sustainably, and with a single low cost upfront fee. It performs like Uber for decentralized storage by connecting people who need to store data with people who have hard drive space to spare. But what is the mechanism that allows Arweave to provide all these benefits? Let's look at how it works. The underlying mechanism that Arweave relies on is called succinct proof of random access, or SPORA. Similar to other blockchains, blocks in Arweave are linked to their previous blocks. Additionally, every block consists of succinct proofs that help prove to the network that a miner has access to randomly selected data from the previous blocks. This mechanism helps Arweave to move away from energy inefficient compute based mining and move towards a greener, sustainable storage based mining mechanism. Keeping this in mind, Arweave has taken the following steps. It uses a randomX mining algorithm that allows miners to compute transactions using general purpose CPUs instead of expensive hardware and fancy GPUs. Miners are required to produce succinct proofs for successfully hashing transactions, and they have a better chance of doing so if they have faster access to the recall data. Hence, they are incentivized to store this data locally. Lastly, Arweave adds a cryptographic speed limit on the maximum incentivized drive speeds to make expensive storage hardware redundant. Using these mechanisms, Arweave receives the following benefits. The barrier for onboarding miners is lowered using general purpose computing tools and mechanisms, giving miners a fairer chance. More miners also means more decentralization and more data replication. And lastly, the storage based mining mechanism promotes organic network scalability in an eco friendly manner. Now, how can general users interact with Arweave? On top of Arweave is a layer called the Permaweb. It looks like the traditional web but unleashes the benefits of decentralization. Users can store any form of data, including entire web applications on it, in a permanent and decentralized manner at low cost and requiring zero maintenance. This data can then simply be queried using URLs with the help of gateways like Arweave.net and passing in the transaction ID. The transaction ID points to the data uploads on the network. Now that we have seen what Arweave is, how it works, and what its benefits are, let's explore building on Arweave by creating a decentralized image sharing application. We shall call this app ArGram. Before jumping into the actual coding, let's get an overview of the key components and the tech stack we will use to bring our application to life. For developing a robust application, there are two primary key components, the backend and the front end. Backend development is responsible for data storage, logic for data modification, unique functional patterns, and adherence to particular standards. In this section, we'll gain an understanding of smart contracts on Arweave and also learn about a distinct data type, atomic assets, that we will be using within our application. The front end focuses on creating a user interface and seamless user experience. It facilitates user interaction with the network through the backend. In this section, we will implement user authentication, provide the ability to create posts by uploading images, retrieve these images for users to view, and create functions to comment and like on these posts. Here is a quick glance of these key components stacked together. A majority of this workshop will focus on creating functions for the front end that will interact with the backend and the network. Now let us look at the tech stack that we're going to use to create this application. The programming language that we will use for both the front end and back end development is JavaScript. Along with that, we will use Permaweb.js, a one-stop library lowering the barrier to building on Arweave. This tool will help us interact with the network in just a few lines of code. Another library, Authent, will help us seamlessly onboard users from Web 2 to Web 3 by facilitating account abstraction. We will use Svelte and Vite as the framework tools for a seamless development experience to create lightweight applications with optimized performance. And lastly, Tailwind CSS will be the CSS framework that will enable us to apply visually appealing styles and enhance the overall user experience. Now that we have an understanding of the concepts and tools that go into building this application, let us dive into the actual coding. We have created a starter repository for this workshop. It is linked in the description below. On clicking the link, you will be redirected to the following page with the following username and ArGram starter repository name. The first step you want to do is fork this repository. So click on the fork button on the top right hand. You'll be redirected to a form with some options. Leave them as they are. Ensure that copy the main branch option is selected and click on the fork button. On clicking the fork button, you will be redirected to the forked repository where you will see your own username followed by the repository name. Now you want to click the code drop down button and copy this URL. This URL will help you clone this repository locally and begin coding. Now open a command terminal of your choice and type the following command: git clone followed by the copied URL. Running this command will clone your repository locally in a folder named ArGram starter. The next thing you want to do is open this folder inside your code editor. If you're using VS Code like I will, you can just do the following command. Typing this will open up a dedicated VS Code window. If not, you can do the same manually as well. With the code editor open, we first want to install the dependencies that we will require to run this project. So we open up a command terminal within this editor and run the following command. I will be using the yarn package manager, so I simply run yarn. This may take a while depending on your setup. We're just going to fast forward this section. With that done, let's dive into the backend development. Smart contracts on Arweave, commonly referred to as SmartWeave contracts based on the standard that they rely on, are stateful. So what does being stateful mean? Every contract has two bits, a state that holds some information and a code to modify this information.
Additionally, any interactions with the SmartWeave contracts are evaluated using a unique mechanism called lazy evaluation. For performing interactions with an existing contract, a user must first evaluate all the previous interactions of the contract with the help of the contract logic and the initial state, and receive the current state. Upon receiving the current state, the user can evaluate and send a request for the new interaction. Another functional pattern that arises out of SmartWeave contracts is the ability to define a contract source and create multiple contract instances out of it. Instances of this contract source can be created with different initial states, and they can have different sets of interactions as well. A few benefits of this pattern are efficiency, modularity, and scalability. The contract logic does not need to be redefined for each instance. Every instance is linked to the contract source by the contract source's transaction ID, and it can refer to the source logic at the time of evaluation.
Now that we have a basic understanding of smart contracts on Arweave, we will explore the contract logic that our application requires. As seen earlier, we are going to use a distinct data type, atomic assets, for our posts and keep the community standard in mind while defining the contract source for the same. The reason we are using atomic assets is because of three distinct features it relies on. As can be seen in the diagram, the core of the atomic asset is the data, or the post in our case. The secondary layer is the smart contract. It consists information like asset ownership, as well as other secondary data like likes and comments associated with the post. And the third layer is the tags, which help with indexing and querying our asset. Atomic assets also have a standard for tags known as the ANS 110 standard for asset discoverability. This includes some standard tags like title, description, type, and creator, which help us identify our content on the network with ease. Lastly, an atomic asset must have the ability to be owned and transferred, so the contract should have functions to get the owner as well as transfer ownership. This can be used to trade assets or share ownership, among other use cases. Keeping these features in mind, we have already defined a smart contract source within our starter repo with some modifications. You can find it under the contract subfolder in the file named handle.js. Every SmartWeave contract in JavaScript follows the following pattern. It starts with an async function definition named handle that takes it two input parameters, the state and the action. The current state is passed in as an input parameter with the help of the evaluator intermediary, and the action consists of the inputs passed in by the user or the caller, as well as the address of the caller themselves. We can split up the contents of the action as follows. The caller of the function must also pass in the function name as part of the action to help the network identify which function within the smart contract to interact with. Moving on to the first function, the getOwner function returns the current owner of the asset and the smart contract. The owner is initially set at the time of creating the contract instance, but ownership can be transferred with the transfer function. The next function is the balances function that gets the user balance for a given asset. The balances are set at the time of contract instance creation. They can be set greater than 1 as well, and ownership can be shared among users by transferring a part of the balances. The code block checks if a target user address has been passed in as an input, and if it is of type string, else it assumes the target address is the caller of the function. Once the target is defined, it checks whether the target has a balance of the given asset, and if it does, then it returns the balance for that given address. The last prerequisite function for atomic assets is the ability to be transferred. The function caller must pass in the quantity of the balance to be transferred as well as the target address to be transferred to. Then the function goes through a series of checks, namely checking if the target is set, ensuring if the target is not the function caller, the quantity passed in is a positive non-zero number, and that the caller actually has the balance they want to transfer. Upon clearing the checks, the balances are transferred from the caller to the target, and the updated state is returned. The ability to fetch owners, their balances, and transfer ownerships make atomic assets extremely powerful, enabling them to create unique applications. After defining the prerequisites, we move on to two additional functions which we have defined specially for our application. The first is the add comment function that enables users to comment on posts just like any other social media application. They take in the comment username and ID of the user making the comment as part of a transaction data object and store it as an object in an array of comments associated with the post. This array of comments will be initiated at the time of creating the initial instance, and we will see that later on. The second function is the like post function, which gives the users the ability to like a post. It begins with a check to see if a caller of this function has already liked the post. If not, the user ID and the like number are stored as key value pairs in the state of the likes object. And lastly, for a bit of error handling, the contract throws an error if an invalid function name is passed during the function call. After defining the contract source, we must upload it to the network for contract instances to refer to. However, as a fun way of group participation in this workshop, we have deployed the contract source for you and added a common transaction ID within our application as well as linked in the description below so that anyone who takes this workshop can view each other's posts and interact with them. With this, we have our backend set up and we can now move on to the front-end development. Frameworks like Next.js and React are the popular choice for development traditionally. However, Svelte and Vite together will enable us to create lightweight applications and provide an optimized performance with hot module replacement, enabling us to see code changes in the browser without requiring a full reload. Additionally, for a stylized building experience, we have added some presentation layer code. This will let us focus on the actual front-end logic of interacting with the network for posting and fetching data. We start with authentication for our users so that we can ensure users can create new posts or view existing posts only if they are logged in. The users can log in with the help of a connect button, either from a nav bar or a landing page. So let us start by creating and handling the connection from the landing page first. We navigate into the source folder. Within it, we go to the pages subfolder and open the start.svelte file. As you can see, we have added adequate comments on where the code must be filled in, as well as comments prompting to existing code. In the general syntax pattern for Svelte, all the interactive functionality or the function logic goes inside the script tags as seen here. Any presentation layer code is found outside these tags. We begin by importing the packages to implement authentication. As you can see, profile here is a cache variable that we have created beforehand. A cache variable is a variable that temporarily stores information. This profile variable will store in the logged in user details until the user logs out or refreshes the application entirely. One of the biggest barriers to the Web3 ecosystem has been the technology needed to interact with blockchain networks. These technologies include wallets, keys, tokens, etc. This has kept consumer use cases limited and prevented masses from onboarding so far, despite the benefits that decentralization and permanence provide. Authent is a library that helps onboard masses to the ecosystem with just a Google account or an email address, enabling users to interact with the network and on-chain applications without the need for or knowledge of technologies like wallets and fees. Permaweb.js is a library that leverages Authent under the hood for various functions, including authentication. For using Authent with Permaweb.js, you will need to fetch an API key from authent.io. On the web page, sign in or sign up into the application using this button. A prompt opens up letting you select the account you want to sign in with. Once signed in, scroll down to the bottom where you will find a button that says Get Your API ID. Click on it. A pop-up modal shows your API ID. Our API ID has been blurred out for security purposes. It is important to keep your API ID secure to prevent misuse by other users. As you can see in this pop-up, there is a form to add a callback URL. So we're going to add localhost 3000 as our callback for local development.
On successful addition of the callback URL, we will copy our API ID and get into the front-end development. For letting users connect to the application, we will use the handle connect function. The handle connect function calls the login function from authent. Make sure you paste your API key or API ID in this section. On successful login, the function returns the connected user's details, which are stored in our cache variable profile. On the landing page, the handle connect function is called with the connect button. On clicking the connect button, first time users go through a registration step. Now we want to implement the same function in our navbar as well. So we navigate to the source folder, the components subfolder, and navbar.svelte. As you can see, it has a handle connect function as well. We paste in the same code. As you can see, the navbar has an additional handle disconnect function as well that enables users to log out of the application if already logged in. On successful logout, the user is disconnected from the application and any user details stored in the cache variable are cleared out. As seen in this if-else statement, if a user is connected to the application, their name is displayed on the button. However, if a user is not connected, they have the option to connect using the same button. The syntax seen here is Swell's implementation of if-else statements within the presentation layer code. With the authentication setup done, let us start seeing this in action in our browser. In the command line, run the dev command as follows. As I'm using the yarn package manager, I will run yarn dev. Then we open localhost 3000 in the web browser to view the outcome. One easy way of doing so is clicking the command or control key on your devices and clicking this link. As you can see, we have a pre-configured style for the landing page. It should look something like this. Great job so far. We've taken the first step to build a decentralized application on Arweave. We can now interact with the connect button and go through some authentication steps. As you can see, upon successful connection, our application redirects users to the page for creating a new post or the upload page by default. The navbar component now displays the name of the user logged in. This is my name. You will see your own name or the name associated with the account you've logged in with. On the left hand side, there is also a drop down where you can switch between pages. As you can see, we have an upload page to upload our post and a view page to view the existing posts. The upload page, as you can see here, has a form for users to post an image with a title, a description, as well as some hashtags. Once the image and title are selected, the create post option will be available. So let us connect this form to the backend and get it working. For submitting the form and creating a post, we must define a function to upload our post to the network as an instance of the contract source we have just seen, and then add some error handling to the front end with the help of some pop-up dialog boxes. Let's begin by creating a new file named post.js. We're going to navigate to the source folder. Within it, in the lib subfolder, we're going to create a new file named post.js. We start by defining a function named post_asset that will require an input parameter, which is the asset. This asset will consist of the user inputs passed from the front end, like the image, title, description, hashtags, etc. Now, when a user uploads an image inside our form, it is of type file object. However, Arweave requires information to be passed in either as a string, a uint8 array, or an array buffer. So we're going to write a helper function that converts these images to array buffers for us before uploading it to the network. Next, we're going to call this converter inside our post asset function. As you can see, we pass in the file received from this asset object to the array buffer function we have just created, and it returns the data type as an array buffer. Now we want to associate some tags with this data. So we're going to start off with an import first. This import will help with data cleanup. Now we have created an array of tags. Within this array, every tag needs to be passed in the following format. It is an object of two key value pairs. The first is the name, followed by the name in string type. And the second is the value, also in string type. Let's look at what these tags are doing. The first tag is the content type or the MIME or media type that we refer to. So for this application, we are only going to use image types. These images are going to have some extensions. As you know, images can be of types PNG, JPEG, etc. So the content type identifies and associates that value with the content type tag. The next, we have some standard tags that help the network identify that this post is a SmartWeave contract. The contract source tag helps us link this instance to the source contract we just saw earlier. However, you can see that the source value is undefined, so we're going to do that now. As you can see, we have pasted in the source transaction ID, which we have created for this workshop as a fun way to interact with all the learners from this workshop. Moving on to the other tags, we have an init state tag, which helps the contract instance define its initial state. The value must be passed as a stringified version of a JSON object. It consists of the following items. The user ID is the address of the creator of this post. The initial owner of this post will be the creator themselves. We're passing in a ticker named ArGram asset to help the network identify that this post has been created through our ArGram application. As you can see, we had mentioned balances earlier. We can assign any arbitrary number to a given address. This helps with fractional ownerships of assets if desired. For now, we're just going to assign 10,000 to the creator of this asset. Once again, we are reassigning the content type as seen earlier. And two main things within this initial state is an empty comments array and an empty likes object. These two objects will help us store the comments and likes associated with our post once the post has been pushed on the network and available on our application to interact with. The next tag is the creator name. The creator name is the username or the name associated with the account that we have just signed into our application with. And the last four tags, as you can see, follow the ANS 110 standard for asset discoverability. So they consist of the creator, as we saw, which is the wallet address of the function caller. The title and the description are passed in by the user at the time of post creation from the front end. The type of the asset is image because we are only posting images through our application at the moment. And lastly, we will take in all the hashtags passed in by the users on the front end and add them to this input tags array as well. With the tags defined, let's see the function to actually create this post. We will be using Permaweb.js's transaction utilities for the same. So again, we begin by importing the function from Permaweb.js. The function is named create and post transaction with authent. As you can see, Permaweb.js is a modular library and you can import specific functions from specific utilities. Currently, the supported utilities are wallets, transactions, serverless functions, etc. This is how we call the create and post transaction function. As you can see, every function used with authent requires your API ID, so remember to post the API ID you have fetched earlier. Within the authent function definition, we must pass in a string that says upload data. This helps the network identify that we're posting some data, that is our post to the network. In the data field, we pass in the actual data, which is the file we have converted to an array buffer format. The tags are the input tags we just created. And lastly, we are going to use bundler. So apart from unlocking scalability for the Arweave network, one benefit of using bundler within this application is that all transactions, all file sizes under 100 KB are free for us to upload to the network. A successful transaction call returns the success status as well as the transaction ID of the upload as part of this transaction object. We want to widen the accessibility of our transactions by registering them with a protocol known as warp. With the help of this warp protocol, we will also be able to view our transactions on a block explorer. So let us do that. We must import two utilities from Warp as seen here. After importing these utilities, we have to create an instance of Warp. We do so as follows. As you can see, we're using the Warp factory utility to make a connection to the main network, which is the Arweave network. Warp also has support for local testing as well as test networks. However, we will not be diving into that within this application. And for the registration, we also need to add the deploy plugin to this connection. With the Warp instance set up, we register our transaction ID with the Warp protocol as follows. And lastly, our post asset function will return this successful transaction object. After defining the logic to create a post and upload it to the network, we want to connect this logic to the form we saw on the front end. For doing so, let's navigate to the upload page. It can be found inside the source folder within the pages subfolder. The first thing we want to do is import the function that we just created. Apart from this, we have some other imports as you can see. The deploy, error, and confirm are pre-created dialog boxes which can be found inside the dialog subfolder. The profile is the same variable that we have seen earlier. It is available for access throughout all our files. We are creating some additional variables to take in as inputs from the user, namely file, title, description, and topics. The file will store the image uploaded by the user. We are also creating some variables to handle the status of the dialog boxes. When the status is set to false, the dialog boxes will not be visible. However, when the status is changed to true, a pop-up will open displaying the respective messages of each of these dialog boxes. Here we are creating another variable called not valid. This is a special type of variable called a reactive variable. A reactive variable is a special svelte variable that updates its values based on the conditions passed here. So the condition we're basically checking is if the user has uploaded a file and added a title. Until the user has done so, the not valid variable will always return true. And lastly, we have an empty function named create post. This function will call the post asset logic we just created along with some error handling. So let us get into writing this function. The first thing we want to do is create an asset object which will be passed as an input parameter to the post asset function we saw earlier. As you can see, the asset object consists of the file, title, description, and topics which is received from the user on the front end, as well as two other key value pairs, the username and the user ID, which is the wallet address of the connected user. Next, we want to use a try-catch conditional statement to call the post asset function along with some error handling. So let us see how we can do that. On calling the createPost function, after the definition of the asset object, it enters the try-catch loop. It first opens up the deploy dialog box showing the user on the front end that the upload process is in progress. Next, the post asset function created earlier is called and the asset object is passed in as an input parameter. Upon successful processing of the function, the output is stored in a result variable. The deploy dialog box closes, all the user inputs are reset, and a confirmation dialog box opens up. In case an error occurs in any of these steps, the deploy dialog box closes abruptly and returns an error dialog box with the appropriate error message instead. Let's try making an upload with the front end. We're back on the upload page of our front end. We have connected this form to the post asset and the posting logic. The first thing we want to do is upload an image. As you can see, we have predefined some image types. Also, it is important to ensure that the file sizes are under 100 KB for successful uploading. We can select a file by simply clicking on this box. A pop-up opens up letting you select the file you want to upload. Upon selection, you can see a preview of the file. Here we have the Arweave logo as a PNG. We can add a title, a description, as well as some hashtags. and finally click on the create post. On clicking, you can see that we have a deploy dialog box. Upon successful creation, we get the confirmation dialog box. Kudos on creating a working form for creating posts to the network. Now that we have posts, let's add the ability to view them. Data on Arweave is publicly accessible to all and can be queried with the help of endpoints. For querying this data, we will use GraphQL, a querying language that passes requests to endpoints. The queries are passed in the form of custom schemas, and the tags defined earlier help with the same. We have a predefined custom query and request in the source folder under the lib folder in the file called queryassets.js. Let's understand the code housed in the file. First, we will look at the schema for querying. If you scroll to the bottom of the file, you will see the function named id query that consists of the schema. We want to replace this bit of code with the query we want. So what is this query doing? This query is basically telling the network to fetch and return transactions with the tag name contract source and the value of the transaction source ID that we've used previously for the sake of this workshop. At the time of creating the post as well, we have passed in this same contract source transaction ID. Hence, when querying against this contract source ID, the query will return all our posts that are connected to this particular contract source. This is an example of how tags help us query information on the network. It is important to note that this particular syntax is important to be maintained in order to pass a successful query, and hence do not make any changes to it. After defining the query schema, we want to make the actual query request. So we have created a function named getAssetData for the same. If you scroll to the top of the file, you can see it. Once again, we have imported some tools to help clean up the return data. On calling the getAssetData function, an empty array named assets is created. Then we make a fetch request to the arweave.net/graphql endpoint. As part of the body of this request, we pass in the query schema that we had created earlier. We get some result as a response for the same, on which we do some cleanup. In the cleanup, as you can see, we are creating a new object for every asset that is received from the request. And we're pushing some filtered data to the new assets array created earlier. The data includes the transaction ID for every asset, the image URL for the same. Traditionally, you can view assets uploaded to the Arweave network by appending the transaction ID to an endpoint gateway. We also have the title and the description passed in by the user at time of the asset creation. We have the type of the file, that is image PNG, image JPEG, etc. We also plug in the other hashtags added by the users, which we call topic for our reference. And lastly, we pull some additional data like the owner's username, as well as the timestamp. Finally, this newly created assets array is returned with information of each asset as an object. However, we have only defined the getAssetData function yet. So let us call it on the view page. We will render the queried data on the view page, which can be found in the source folder under the pages subfolder in the file name view.svelte. This file may show some errors when we open it. However, these will be resolved once we write the code needed. We replace this prompt with the actual code that we want to pass in. This code is creating a variable named asset data that calls the getAssetData function. So anytime the asset data variable is referenced, this function will be called and the data returned from this function will be assigned as the value for asset data. And as you can see, the errors have disappeared as well. As you can see here, we're making a dynamic call to the asset data variable. So it calls the getAssetData function and stores the output of the same inside this temporary variable called assets. As we remember, assets was an array that is returned by the getAssetData function. So from the asset, we separate each object for every asset. After separation, we render each bit of information as its own element. As you can see, we're rendering the image, the title, description, the hashtags, etc. In case no image has been posted on the contract source transaction ID, we will throw a message saying please post an image first. So let's look at this on the front end. We navigate to the view page with the help of the navbar. We can see our post right here. It has the title Arweave Frontier along with the image which we posted. It has my username here, which is fetched from the user account I have signed up with. We have the description as well as the hashtags. With the help of Authent and Permaweb.js, we have successfully interacted with Arweave with the help of Web2 technology like email addresses. Awesome, another milestone accomplished. Now, as you can see, these posts also have two additional bits. One is the option to post comments, and the other is to like a post. Let's start by giving the users the ability to comment. Every post, as we saw on the front end, has a dedicated comment form, and this comment form is linked to the post with the help of the transaction ID for the post. Now, for handling comments, there are three functions that we need: a function to add comments, a function to read newly added comments, and lastly, to fetch existing comments when the component first renders. We'll start by defining the add comment function. To work on the comment component, you can navigate to the source folder. Inside the component subfolder, find the file named comment.svelte, and let's build on it. We're going to replace this prompt with our code. As you can see, calling the add command function goes through a try-catch conditional like we've seen earlier. This opens the deploy dialog box to show that the commenting is in progress. Next, we call the write contract with authent, which is another one of Permaweb.js's functions. As you can see, we have imported the write contract with authent from Permaweb.js's contract utilities. The contract utilities help us create and interact with existing contracts. As our atomic asset has a contract associated with it, we will use the write contract with authent function to interact with it. Once again, remember to pass in the API ID fetched earlier. This time the authent function is defined as a send transaction string. This is to tell the function that we are interacting with an existing contract. The data must be passed in as an object. Within this data object, we pass in the ID of the post to interact with. This ID is received from the front end. As you can see, we have created a variable called ID and we are exporting it. If we quickly look at our view page again, where we are plugging in the like and the comments component, the exported ID is being assigned the transaction ID for the corresponding post. This ID is then passed into the comment component, which we see right here. In the toContract function key, we want to pass in add comment. If we remember at the time of contract creation, inside the contract source, we had defined functions named add comment and like post. So for adding a comment, we want to call the add comment function. As part of the transaction data, we once again add a link to the add comment function that we want to interact in the contract. Next, we pass in the input parameters that the add comment function requires, which is the username passing in the comment as well as the comment text itself. As our view page has multiple posts, each with their own comment section, we want to ensure that if a user has passed in comments on multiple posts, each comment is associated with their respective posts. Hence, we have created a comments object, and the comment for a given post is indexed by the ID for that post. On successful comment addition, the deploy dialog box closes, the input from the users is reset, and the latest comments are fetched. As you can see, this is throwing an error as we are yet to define the read comments option, which we will do now. For reading the comments, we are using the read contract with authent function from Permaweb.js's contract utilities. Once again, we pass in the API ID as well as the contract ID or the post ID, which is received again from the view page inside the comment section associated with each post. From the result, we access the current state of the given post and the associated contracts. And within the state, we look up the comments array that we have created. This will show us the existing comments as well as the usernames of the users who have made the comments. This read comment function, however, only works when it is called. So when we log into our application or we first render the application, these commands won't be accessible until the read commands function is called. Hence, we use an on mount. Inside the on mount, we call the read commands function on first render of the application or the component and store all of the commands in a temporary array named comments array. This array helps us render the information from the comments array, which is the comments passed in by the users as well as the corresponding usernames as seen here. So once again, let's test this on the front end. I'm going to pass in a comment on my own post. As you can see, a dialog box opens up, and on successful comment posting, we can see my comment is here as well as the username of the commentee. Great. Now we have the ability to comment on posts. So we're going to do the same thing for likes. The last feature we're going to implement is the ability to like posts. So let's navigate to the source folder, within it the component subfolder, and open the file named like.svelte. Similar to the comment component, every post has a dedicated like component linked to it by its transaction ID. The post ID is passed into the like component on the view page and received for use within the component. This helps the network associated likes with a given post. For the like component as well, three functions are required. A function to like the post, to read new likes on a post, and to fetch existing likes when the component renders for the first time upon app refresh. Let's start by implementing the like feature. We start by working on the like post function. Similar to that for adding comments, we call the write contract with authent as we're making a write to our post. Remember to add your API ID. The authent function will be a send transaction because we are interacting with an existing contract. The contract function we want to interact with is the like post. There are no other input parameters required. Upon successful interaction with the contract, our function fetches the latest likes on the post and results it in a variable called likes. This variable throws an error as we still have to define the read likes function, so let us do that. Within the read likes function, we call the read contract with authent function, pass in our API ID as well as the post ID or the contract ID that is associated with the post. This ID is once again received from the view page. As you can see, we have an exported element named ID. On the view page, every post ID is associated with this variable. Finally, on a successful response, we look up the state, and within the state, we look up the likes object and return the data from it. Lastly, we want to fetch and render the likes when our application is refreshed. For that, we use a simple on mount as before. The likes variable is then rendered alongside our post. If a user has already liked, the like button is unavailable to them. Otherwise, they can click on the like option and add a like to a given post. So let us see how the like feature works on the front end. Now I'm going to test adding a like to my own post. As you can see, the like number is 0 and I have the ability to like on this post. So I'm going to click the button. Upon successfully liking, the like number has incremented and now the button is unavailable for liking. So there we go. We have the like feature as well. Great stuff, guys. Pat yourselves on the back and grab some ice cream. We have just created a full stack image sharing application on Arweave. Let us take a quick look at what we've accomplished today. We have understood the smart contract standards on Arweave, looked at various functional programming patterns and their implementation. We also learned about distinct data types like atomic assets, implemented user authentication helping onboard users from Web 2 to Web 3, created posts as atomic assets, queried for these posts on the network and rendered them on the front end, and interacted with these posts, modifying their state by making calls to the asset contract and viewing these changes in real time. Congratulations! You've just completed the Arweave Frontier workshop. Thank you for joining us on our adventure through the Permaweb. Share your builds with us on Twitter. You can find the links in the description below. Happy building!